Hello. Today I'm going to talk to you about the fall of Domino, the pre-installed hostile downloader that we were able to find on some Android devices. I want to tell you a story a bit differently though. Usually when you have a story of a malware, the presenter starts with the chronological order of events. So you get to see different versions and you get to see how they progressed. Basically, what you get to see is the story from the malware author's perspective, how they developed the whole attack or how they developed the whole malware. Today, I want to present you a different kind of story, a story of how we found malware and the story from kind of behind the scenes. So instead of presenting it chronologically according to the versions, I will present it chronologically from the point of my view. So we will start with going over how Domino was found and discovered. Then we will take a look at how it was installed on devices and what are the components of Domino. And these three questions are the questions that every malware researcher has to ask at some point. So whatever kind of malware you are looking into, whether it's Windows, Android, something else, you have to find out, you have to first have a lead and find out how it got installed on the devices, and then what is it doing, what are the components, what are the different parts of that malware. So let's start first how it all started. So it all started with a Malwarebytes post on xhelper. There was a blog post detailing an adware app that appeared on devices, and it appeared to be unremovable from the devices. So it was speculated that something pre-installed is responsible for this app, or that the app itself is in some way pre-installed. Then there were two follow-up blogs, one from Kaspersky and one again from Malwarebytes. And these blog posts seemed to point to Triada, both the Malwarebytes blog post, which mentions that somehow Google Play is involved in the process, but based on the blog post description, it looks like this is the Triada backdoor, which used to inject into Google Play process in order to install apps. And this is consistent with what is happening with xhelper. And then Kaspersky confirmed that there is a connection between Triada routing Trojans and xhelper. But this is not all. There is more. So when I took a look at the devices that have xhelper on it, I also took a look at the system images for these devices. And the system images for these devices had a different kind of malware as well. So I looked into the binaries and the whole system image, and I found that there are additional binaries on the system that have privileged access. There were also modifications done for the AOSP, Android Open Source Project browser app, and the settings app as well. And there were some modifications in the Android framework, and they all worked together to download other apps and also do app fraud. So let's take a look at these modifications and these components. But the first thing we have to look at is the installer package. This will let us know how Domino was installed. We were fortunate enough to find the whole source code zipped in an archive, and that source code contained the binaries. It also contained the actual source code in Java for some of the modifications, and it also contained a README file and some additional information. So this is the whole directory listing of the source code package of the zip file. And you can see a bunch of different files that make up this zip archive. First is one with the custom system properties. So Domino was controlled with a set of system properties that were specific to Domino. You can see that there are also SE Linux policies. We will talk about them later on. There is a list of files to modify or add. So the file list.txt is basically a roadmap on how you install Domino on an Android device. There are also source code files that show the changes in framework. So you have something like resolver activity and package managed service. We'll talk about these changes later on. You have also changes to browser, as I said. You have the README file, which is really useful. And you have the binaries that I mentioned. I will be using the name service and daemon for these binaries. They are not really named service or daemon. This is the name that the malware author is using inside the binaries. And the names of actual binaries are different depending on the version. So in this source code package, you can see something like HTFSK or RBN, but they will depend on the Android version or the device that has Domino. So the README file, as I said, contains some useful information. It is written in Mandarin Chinese, and when you translate it, it translates into please integrate according to the comment keyword Domino. File list.txt is a list of files that need to be integrated, and the read phone state permission is needed by the browser. So please ask your company to handle it. What they mean by please ask your company to handle it, it just means that this permission has to be pre-granted to the browser app. So the OEM has the ability to pre-grant some of the permissions to some of the apps so that the user is not asked to, for example, give the microphone permission to the phone app because it's an obvious permission that will be needed in order to use the phone app. So let's take a look how the keywords are used in order to integrate the code to your platform. You can see that there are these comments in XML and there are similar comments in Java files and similar comments used throughout the source code package. So you have something like add S and add E. S stands for start and E stands for end, and all of them are, as you've seen in the README file, keyworded with Domino, which means that if you just grep for Domino, you will find all the changes. So for example, these are the changes that are needed in the Android manifest.xml for the browser. And you can see that there are different permissions added. One of them is the read phone state mentioned in the README file, and there's a bunch of others as well that are only used by Domino. That's why they have to be added to the browser. Okay, let's take a look at binaries then. So as I mentioned, there are two binaries. One is called daemon, which is slightly misspelled by the authors, and the other one is called service. And they have two different functions. So the daemon binary creates the databases that will be used as a kind of configuration for both the other binary and some other parts. And you can see a couple of tables here. So you have something like URLs that will be saved and used. You have text messages, ZSMS, for example. You have some package names and stuff like that. So just based on the tables and the contents of the tables, you can see that there will be some clicking component because you have something like click URL and you have something like IMP URL. So it's either an adware or a click fraud, or at least it displays ads in some way. This binary also makes HTTP connections to a specific URI patterns. You can see that they all start with pass web API, and there's some kind of a /rest/service then, and different URLs that are used to download different things. Interestingly, the same binary adds fake text messages into the SMS table. So it locates the database that holds all text messages on an Android phone, and then creates new text messages. These text messages can be either added to an existing thread. So for example, if the text message is coming is supposedly coming from a number that you already have in your text messaging app, then you can add it to that thread. And if it's from a new number, you will have it in a new thread. So it's fairly complex. It's not a simple code. I don't really know why they are adding fake text messages. Based on the whole Domino, it may be used to do something ad related, because the whole Domino is actually about ads and as you've seen, clicking and all that. So maybe the text messages are something ad related. The other binary, the service one, is used to install apps, and you can see that there's a pm install command being called on an APK file that is on the SD card. This APK file is downloaded by the browser. This also is a way of hiding the network traffic, right? Because you expect the browser to be downloading files. So they are using browser to do just that, download the APK file. And it also activates applications. So whenever the app is installed on Android, it won't be activated. By that, I mean that the user has to click on the app in order to activate it. And this binary takes care of that. It starts the activity that you define, or the CNC defines, and it will start up the application without user interaction. That's why it's needed here. So you have two binaries. One is communicates with the CNC, downloads configuration, and does this fake text messages. And the other one is mostly about installing apps, activating apps, and making sure that the apps are running. And this is what most probably is downloading Xhelper. As I said at the beginning, there is a big correlation between the devices that have Domino and the devices that have Xhelper. So most likely this is one of the install vectors. And the other thing that they had to do is the binaries by themselves cannot really do much unless they have a specific SLNX context, which is responsible for permissions. So you can see that the binary that installs apps, the service one, is running as shell, as a shell user, which means that the installs are handled the same way they would be handled if they came from ADB. And that means that the Android OS doesn't differentiate between an install coming from the service binary and the install coming from the ADB. So it's the same experience, let's say. And if you take a look at apps that are installed, they will look like they were installed by the user from ADB. And the other one, the other binary is running as radio, which also has elevated privileges. And as you can see, they both have access to the network, and they both have access to the SD card, which is needed to write that APK file and read that APK file. There's also a system property that controls Domino, and that system property that I mentioned at the beginning is feature browser ext, probably stands for extension, and if it's set to true, the binaries will start. If it's not set to true, the binaries will kind of be turned off. So this is basically the switch that controls whether Domino is running on a specific build or is not running on a specific build. But binaries are just part of the story. There are also browser and settings modifications. So browser and settings are apps that are part of the Android open source project and come with your phone, but they obviously can be modified in the process of creating the system image, and additional code can be added to them. So I already said that browser is using to download the APK files, and it downloads any URL that is supplied by the CNC. So for example, it can download the APK file, but it can download also anything else. There are several checks done So there is one that checks the browser feature ext. As I said, this is the huge switch that controls whether Domino is running or not. So if it's set to false, this modification also won't run. Then it checks the silent period. This is the Boolean value that is supplied by the CNC. So if it's in a silent period, it won't download anything. It also has the check black method. This is again a Boolean value supplied by the CNC. I don't know what's the difference between these two. Maybe there's some logical difference on the CNC side. And it checks whether the phone is connected to Wi-Fi. So it will only download stuff if the phone is connected to Wi-Fi, which is good because it doesn't use data in that way. And is also this also makes it stay slightly more silent because you're less likely to see network usage on Wi-Fi than you are to see the network usage on your data plan. And there is an affiliated search. So what happens is whenever you search for something, the browser will change your search engine to a different one. That different one has additional parameters added to the search, the M, C, and K parameters. I wasn't able to find the search engine that they are using, but based on the M and C and K parameters that are kind of hard-coded or come from CNC, it may suggest that they are using some kind of an affiliated search instead of the search engine chosen by the user. And it's also displaying ads when the screen is off. So it checks whether the screen is turned on, and then it checks that a couple more times. And when the screen is really off and it's sure that the screen is off, it will send an intent to view a website. And this is an ad website, and it will save the refer URL parameter value. And when it saves that refer URL parameter value, it will use it later on. And I will show you how this is being used later on. But the idea here is to display the ad when the screen is off. So pretend that user saw the ad and was redirected to some other URL, and that URL had the refer value that will then be used. So this brings us to framework modifications. The browser does kind of all the online activities that are needed. And this makes sense because the user is less likely to see that browser is doing something nefarious when it connects to the internet, right? The whole point of the browser is that it connects to the internet. So the framework modifications are the install referrer value. It is being intercepted in a really interesting way. So the framework modification actually looks for all the broadcasts, and it looks at the broadcast intent locked method. This method is called for every intent. So it intercepts every intent, but it checks whether the intent is install referrer. And the install referrer is an intent that is sent when the app is being installed from Google Play. And it contains the referrer that referred the install. So it's part of the ad process. When you see an ad for a particular app and you go and install it, then it will send the install referrer saying, oh, the user came from this particular ad. And the ad was displayed when the screen was off, so the user obviously didn't see it, but the referrer value was saved. So when the user installs the app and the install referrer broadcast is sent, it will then remember the referrer that was saved when the ad was displayed on the lock screen and use that referrer instead of saying that the user simply navigated to the app and install it. So it will misattribute the installation to the ad that was shown when the screen was off. So the whole thing comes together in like 4 major steps. First is that the settings app downloads a list of ads to display when the screen is off, as I said. Then it visits the ads when the screen is really off. It saves the referrer value for later. Then when the user goes to Google Play to install the app, the referrer is overwritten. So instead of saying that the user navigated to the app and using the real referrer value, it will use the referrer value from the ad that was visible when the screen was off. And the broadcast is intercepted and substituted. Yeah. So this is the whole point of these modifications. It also, in another part of the code, it also makes sure that the correct browser is opening a link. So whenever you have an option to open a link using different apps, you have the option to choose the activity that you want. So you will get a dialog similar to the one on the left-hand side where it says, do you want to open it with YouTube, or do you want to open it with Chrome, or do you want to open it with something else? And this is done by choose best activity method. And this choose best activity method basically checks whether the link can be opened using multiple apps. If there is only one app, it will use that app because there's no choice for the user. If the user choose the app in the past and said, this is the app that I want to be used to always open these kinds of links, it will also open that app. But if there is more than one and the user didn't make that choice, it will display this dialog. So what the modification does instead is it first checks that system property that I mentioned, but if this system property is set to true, it will check whether the modified Android browser with the modifications that I mentioned before is able to open that link. And if that browser is able to open that link, it will automatically navigate to that browser. It won't present the user with a choice or anything like that. It will just open it in the browser. So as long as the modified browser is able to open that link, it will be used to open that link. So let's sum up everything that we've learned. The first thing is that Domino is a pre-installed hosted downloader which displays ads and changes the ad referrers. This is what I was talking about a second ago. It is most likely used to distribute xhelper. It may be used as one of the methods to distribute xhelper along with Triada. It may have connections to the Triada malware family. It's not clear to me whether Triada and Domino are separate distribution channels, or maybe they are controlled by the same group behind the scenes and are distributing xhelper using two different channels. So it also comes as a source code package that we've seen. This source code package has instructions on how to combine Domino with your existing Android open source project code and how to include it on the system image. It makes sure that the SLNX context is right, that you added the required modifications, that the system property is there and it's set to true. One thing that I didn't mention is that Domino targets devices with Android 7 and below. We haven't seen anything Domino related on Android 8 and later versions of Android. They might have changed the whole tactic, they might have changed the whole code, but we haven't seen anything similar to Domino or Triada on newer Android devices, which is really encouraging. So this is all. Again, thank you all for listening, and thank you to the researchers that published the Malwarebytes and Kaspersky blog posts. Yeah, that is all. Thank you.